So let's look at our timer. I've already set the green button up. I'm going to have to create a tag, and I'm going to call this my field timer. I have my factory IO up here, so I already have a field timer, so we'll just use it. And so if I need to, I can right click and hit new and create my tag. And so it looks like we have a field timer, and we'll just start with 1,000 seconds. I will use a time on. We're going to finalize all the edits, and now I will hit the run button. Hopefully it starts working. Should start working now. There we go. And so we'll see that I can change this preset in this timer. Let me move it up a little bit longer than 1 second. That's for 5 seconds. Remember that there is no time base, so it's in milliseconds, 5,000 milliseconds. And we'll see that it just begins timing. Once it's done, the enable bit is activated. I can also monitor this address if I so choose. See if we can pull up the monitor window by right-clicking and go to monitored. This is how we'll troubleshoot too. So we'll hit monitor, and it'll come up with my field timer, and I can see the individual parts of it, and I can see how each one of them works. Notice that the enable bit comes on. Now see that TT bit, and then it goes done. You see the done bit activate. And so if I had to do like a pulse, if I want to do a pulse for 10 seconds or something, or maybe I need to do an oiler. They're great if you have a high-speed bearing that needs oiled every 2 minutes or something. You can spray it with some oil, and it works great for that. Now I would like to show how a TOF timer starts working. We're going to edit that. I don't have to do anything but change the designator. See that, TOF? We're going to hit yes. And so here we see that we're going to hit the button. Nothing happens, right? It begins to time off. So when the logic to the left of a TOF timer goes true and then false, it begins to time. So let's go through here and monitor. Let's watch it. So it resets when I first hit it, and the enable bit is active because the logic to the left is true, so it becomes enabled. Same for both timers. The done bit is already on, and so when I release it, it begins staying on, and the done bit will stay on until it reaches the end and it goes off. So that's for what could I use that for? Let's say I have like some kind of mill or machine with a heavy torque load, like a 50 horsepower motor. Okay. And so when I hit the off button, I really don't want to turn it off. Okay. I want to turn it off, but I want to apply the brakes for 20 seconds. And I could use that TT bit to apply the mechanical braking system for 20 seconds after it goes off. You with me? So I could energize a clutch solenoid with that TT bit and apply brakes for a preset time after I turn the machine off. Next, we have a RTO, or retentive timer. So I'm going to go ahead and do another edit. Change that to an RTO. Probably never use this. Like I said, there's not a lot of use for them. We're going to have to change the accumulated value to 0. It got stuck on me. I'm going to hold the button in, and it maintained its count. So I'll push the button again, and it counts a little bit more. Let's look at the state. Monitor. Notice that it has kept its count. I've pressed that button for a total of 1,600 milliseconds. I'll enable it. See the TT bit on, but then it stops. And now it's done. Notice what stays on is the done bit. The only way to get that done bit off is either unlatch it or turn it off, or apply a reset function. RES with the same address. So it has to have a reset function. And actually, what the logic I did just made it behave like a TLN timer, but it could be a separate button. And so that's kind of your basics for control logics timers.